Hi, everybody. Today, you're going to see the title at the top of your page, and what we're going to do is we're going to work through some measurement and money applications. Like, I could also call this like measurement and value applications. But what we're going to do is we're going to throw in kind of two other areas, two other types of application questions that we can deal with. So let's jump right in, and we're going to get going with problem one. So, what I'd like everybody to do, pause it right now and give one a read. Okay, we're back. So, you take a look at problem one, and the problem eventually asks us to find the side lengths of that triangle. So, we know that we are finished the problem when we have found all the side lengths. Okay. Yesterday, we were kind of forced to begin every single problem with a let statement. We knew that we were going to use some algebra to solve it. That's our expectation. And so if we're going to use that algebra, then that means we need to have a variable, so we have to define it. Well, for everybody who doesn't really enjoy writing let statements, you should really love measurement problems. Because if we're talking about a measurement problem, then we're talking about a shape in some way. We're talking about perimeter or area or volume, and those all require a shape. And so, if it requires a shape, then how about we just draw and label a diagram? So, if I was to take a look at this question, the question says 3 sides of a scalene triangle. So, I'm going to go through and I'm going to draw a scalene triangle. Well, a scalene triangle, if we remember, is a triangle that has 3 different side lengths. So I just drew a triangle that looks like it has 3 different side lengths. I didn't draw a right triangle because I don't know if it's a right triangle. It could be. I can have a right scalene triangle. But I want to make sure that whatever I put into my diagram, it's not going to cause me to assume anything. Hey. So you'll notice that that blue shows that I have my triangle. It's scalene, no other assumptions. Okay, there's my scalene triangle, and it now tells me that the side lengths of those are consecutive odd integers. Okay, consecutive odd integers. We know consecutive means in a row. And so instead of writing let x represent then we can just clearly label our diagram. So, similar to what we've talked about in the past, most people tend to like to make the smallest thing be x. That's our unknown. And whether you label it an x, an a, or whatever, who cares? But as soon as I define my smallest side as an x, then my other 2 sides have already been defined. So, if x is my smallest side, then my next bigger side must be x plus 2. Don't overlook that they're odd integers, and all odd numbers are 2 apart. So if my smallest one is x, then the next odd integer must be 2 greater, and then the next odd integer must be 2 greater than that. Now, we're going to likely skip over writing x plus 2 plus 2, and instead just simplify your plus 2's and write plus 4. Okay, there we go. What you have on your diagram then fully explains to your reader what x represents. Your reader can see that x represents that one short side. Okay, well now we can use our next sentence to try to solve the problem. The perimeter is 33 centimeters. We know perimeter is all of our lengths added up. It's the distance outside an object, the distance around it. And so if I took one side and I add it to another side and I add it to another side, then that gives me 33. Now that blue equation just becomes something easy that we can work our way through. Let's go ahead and let's solve. Okay, so I have 3 x's and a 6 on the left side. I can get rid of a plus 6 by subtracting 6. and I can get rid of a times by 3 by dividing by 3. And there we go. We got x equals 9. Okay, did we answer the problem? No, because the problem asked to find the side lengths, which means I need all of them. So what did we just find then? Well, we found out what x was. And if I look back onto my diagram, I notice that x was that side. So I can make that substitution then, and I can find my other sides. So therefore, well, what are my other sides? Well, I have 9, and I'm talking about centimeters. My other side would be x plus 2, so 9 plus 2, 11 centimeters. And my biggest side would be x plus 4, so 9 plus 4, 13 centimeters. Now, you better bet that I'm going to take one quick peek and see, do those 3 sides form consecutive odd integers? They do. I'm feeling pretty confident. And there we go. So hopefully not too painful on that first one. And the biggest thing I want us to get out of that one is, if we have a measurement problem, let's use a well-labeled diagram instead of a let statement. Okay, let's try the next one. Okay, what we see in problem 2, the length of a rectangle is 6 centimeters more than its width. The perimeter of a rectangle is 52 centimeters. Find the length and the width. Okay, so we're going to build this one up together. Step 1, now that I've read the problem aloud, let's go ahead and let's produce a well-labeled diagram. So I want you to draw your diagram, and I want you to label it. Label it with the expressions to represent the length and the width. Okay, pause the video now. Okay, we're back. So it said that we had a rectangle, so I'm going to draw my rectangle. Now, this is a key thing where I could do this and say that I have length and width, but now I'm working with 2 different variables, L and W, and I do not want to do that. I want everything in one variable. Well, my first sentence says that the length of the rectangle is 6 more than the width. So we really have 2 options here. If we stick with we like to make our variable the smallest thing, then I would expect to see a lot of X's or maybe W's labeled on that width. That is going to make my length 6 greater. So I take my X plus 6 or my W plus 6 and so on. Hopefully our diagram matches up. Okay, if we've got that, now what I want everybody to do is to try to build an equation to match this. Okay, pause the video now. Okay, we're back. So for us to calculate the perimeter of a rectangle, we could just add up all those side lengths, but there might be a little bit of a faster way. I'm hoping that we recall that the perimeter of any rectangle is 2 lengths plus 2 widths. So I'm going to have my 2 lengths and my 2 widths, and if I combine all of that, then that gives me the total distance around. By using that formula, I may have jumped into this equation. The perimeter is 52, my length is x plus 6, my width is x. And if we have that orange equation, then I think we are doing great. Okay, what I want everybody to do now is to go ahead and pause the video and solve that equation. Pause it now. Okay, we're back. So let's go through the process then of being able to solve that equation. So if I crank out that equation as fast as I can, then I'm going to have 52 equals, I can expand in that 2. Maybe we're getting a little more comfortable with our equations, and we can see that we're going to have a 4x on the right side. I want to get rid of that plus 12, so I need to minus 12. And I solve for x and get an x value of 10. Okay, what did the question ask us for? It asked us for the length and the width. Well, what did we just find? Well, if I take my x equals 10 and I look back to my diagram, I notice that I just found that dimension. I just found my width. Well, you could formally, as we did with our numbers problem, sub x equals 10 back into x plus 6. However, I'm going to bet and say most of us will just do that mentally. And instead, we're going to jump to a red therefore statement of saying my width is 10. Because it's a rectangle, we can often describe the dimensions of a rectangle using the by word, like multiply. 10 by, and now if we replace our x with 6, we get 16. Or sorry, our x with 10, we get 16. The only thing we forgot to do, include on our units. We have 10 centimeters by 16 centimeters. There's the length and width of our rectangle. Okay, hopefully you guys don't mind those measurement problems and that we're able to work our way through with a well-labeled diagram. Okay, that does mean you guys need to know how to calculate the perimeter or area of a rectangle, the perimeter or area of a triangle, and so on. Okay, let's jump into some different types of. Okay, what you see in problem 3, we're going to change gears a little bit. And so you'll notice that we have a different type of problem. I want you to pause the video and give that problem a read. Okay, pause the video now. Okay, we're back. So, when you read that problem, I'm hoping that we were able to kind of break down the information in the problem into 2 general areas. I want you to notice that at the end of the first sentence, we had this statement that said that we had a total value of $8.50. You'll also notice that in the second sentence, we had this comparison or statement about the quantity of coins, how many of those coins we have. So what I'd like you to do is to start looking at some of these problems in 2 areas. Number 1, we have a quantity situation. How many of something do we have? And then step 2, we have a value of something. Okay, yeah, but what's like the worth of the coins? My suggestion to you would be to follow a 2-step process. Let's use the quantity of coins to create our let and then statements, and then we can use the value of the coins to create our equation. Okay, let's give this first one a go together. Okay, look at the red underlined statement. It says there are 3 times as many nickels as dimes. So maybe the way I started off is I'm going to say that I'm going to let, and maybe even in this instance, I might use D, just so I don't lose sight that I'm talking about dimes. Like I won't call them X. You can, but a lot of people may like to use D just to remind them that that's the dimes. So I'm going to let D represent the number of dimes. Now, as you guys get a little bit more practice, some of you are going to want to write this. Let D equal dimes. You need to know that if you write that down, you get 0. Like, what is it about the dimes? Is it the quantity of dimes? Is it the value of dimes? Is it the year the dimes were made? Like, there's so many things that last statement is not specific enough. We need the red statement. Now, if we allow D to represent the number of dimes, then in that red sentence that we underlined, I could then say, then 3D is the number of nickels. Notice the sentence says, I have 3 times as many nickels as dimes. So if D is my number of dimes, then my number of nickels must be 3 times that amount. Okay, I just used my red underlined statement to create my let and my then statement. Now what I'm going to do is I'm going to jump up and I'm going to use my blue part of my sentence to build my equation. Okay, I've been told that those nickels and dimes have a total value of $8.50. Okay, first off, this is your number one mistake. And I just want you guys to see if I wrote this down. Dimes plus nickels equals $8.50. I hope that you guys can see that that blue equation is horribly wrong. Like, just remember what that left side is. That's the number of coins. Well, you need to tell me, how do you have a number of coins that equals 8.5? How do you have 8.5 coins? You can't. You have a coin or you don't have a coin. It's illegal to cut coins in half. So I want us to look back on that blue equation and realize what the mistake was. I'm trying to build a value equation, but I didn't incorporate value over here. That's what I need, the value of them. So what I need to do then is I need to put my value on my quantity. And this is actually pretty straightforward. How much is each dime worth? It's worth 10 cents. Notice when I change 10 into a dollar, it's equal to 0.10 or just 0.1. Well, how much is a nickel worth? And I'll use N for nickel. We would say like it's 5 cents. Well, that's in cents. Or that's 0.05 in terms of dollars. So I need to put that worth on my number of dimes. I need to put that worth on my number of nickels. Okay, I'm going to erase all that stuff. You guys are good to rewind the video if you need to. But what we're going to do is we're going to construct a new left side of our equation. Okay, I'm going to start off with my dimes. How much is each dime worth? It's worth 10 cents. So let's put that value on the dimes. What 0.1D says is take 10 cents and multiply it by your number of dimes. So that's going to tell us how much is that pile of dimes worth. Now what I need to do is I need to add to that 5 cents for every nickel. And notice that I didn't put N down. Look back up in your then statement in red. We've been told that 3D then is the number of nickels, so I need to put the worth of 5 cents on my number of nickels. Now, that equation looks really, really ugly, but it's actually not that bad. If we clean up the second term and we take 3 times 5 cents, then that's going to give us 15 cents. That's equal to $8.50. Now I can collect my D's on the left side. So I get 0.25D is equal to $8.50. And now I can divide out 8.5. Some people will just like to write $8.50 because it's money, divided by 0.25, and I can calculate. So hopefully we go through, we push a little bit of buttons. This would be a calculator issue, I imagine, for most. It shouldn't need to be, though. If we recognize that 0.25 is just quarters, and I said, well, how many quarters makes up $8.50? I would hope we'd be able to go, well, 4 quarters makes up $1. I have to multiply that by 8 to get up to $8, but then I have to add on 2 more quarters to get to $8.50. That maybe we come in on a 34. I totally know that you are going to go through and you are going to push buttons on that. That's totally fine. Okay, we get down to D equals 34, and we're good to solve the problem. The question said, how many coins are there? That means we have to answer the question, how many nickels, how many dimes? Well, the nice part is we just found out what D was. So if I look back up into my then statement, I can use that to tell me how many nickels. And so just as before, you can write sub D equals 34 in to 3 times D. But I'm going to imagine that most of you are going to say, therefore, 34 dimes, and then calculate 34 times 3 and say 102 nickels. And there you go. Okay, hopefully not too bad. I want to talk a little bit about something that can happen that can really help you out as well. So what I'm going to do is I'm just going to erase a little bit up in the top right corner, and I'm going to add in, let's say I made a horrible, horrible mistake. Like, it's actually not that bad. It's just a skill and drill mistake. But let's say that this line instead said 0.1D plus, and let's say I made the mistake of, instead of a nickel being 5 cents, I said it was 0.5. So I actually put a label of 50 cents on a nickel. But let's just say that I did that. I would now have this as my equation. And if I made that mistake, I might not notice I made that mistake. And so then I'm going to go through and follow all the same steps that I just did. So now I'm going to go through and I'm going to divide my 8.5 by 1.6, and I'm going to get that D equals 5.3125. Okay, I'm hoping that everybody can tell that we must have made a mistake. And I mean must have made a mistake. Because how can I have 5.3125 dimes? I can't. I can have 5 dimes or I can have 6 dimes, but I can't have 5.3 dimes. So there is something really nice about, and I'm going to circle back in our original equation, that calculation. There is something really nice about that. Because if I go through and I do my division, I know that my answer has to be an integer. More importantly, it can't be negative. I can't have a negative number of dimes. My answer has to be a whole number. That's nice for us. It means that if we ever get down to a case like this, we go, oops, I know I goofed up. We go back up, we look, and we go, there's my mistake. It should have been 0.05. We make our correction and we move on. Okay, what I want to do is I want to get a little bit more practice with value statements. Okay, let's try the next one. Now, okay, so let's take a look at question 4. Same thing as usual. Let's give that problem a read. Okay, so pause it now. Okay, we're back. So you read in Michelle's piggy bank, there are dimes and quarters. There are 24 coins with a value of $4.65. How many does she have? How many of each does she have? So let's start it off then. We notice there's a statement, information about the quantity of coins. But we also know there's my information about the value of coins. Okay, I want us to work through this one on our own as much as we can. So, first thing I want you to do, let's build our let and then statements based on our quantity information. Okay, I want you to go ahead, build your let and then statement. Okay, pause the video now. Okay, we're back. So, hopefully we said, oops, wrong color, that we said let, And in this case, it doesn't give me any information about which one was less than the other one. It doesn't tell me which one I have more of, dimes or quarters. So maybe I just said, let's let D represent the number of dimes. Well, if D is the number of dimes, then my total number of coins, 24, minus my number of dimes, D, has to be what's left over as quarters. So 24 minus D is the number of quarters. Okay, when it gave me the total number of coins, then as soon as I said D was one of them, the other one must have been 24 minus D. Okay, I just used my quantity information. Now I'm going to use my value. Okay, what I want everybody to do is build their value equation. Okay, pause the video now. Okay, we're back. So, I have a total value of 465. So, I know that each dime is worth 10 cents. And I know that each quarter is worth 25 cents. So notice what I have on the left side of my equal sign is the value of dimes plus the value of quarters. What is that total value? 465. And so now that I have that equation, now I can kind of hopefully shut my brain off as best as I can, and I can go through and I can solve my equation. So on that second one, we have to expand in our brackets. So 0.25 times 24 is going to give me 6. Then minus 0.25D. And that's my 465. On the left side, I'm going to have negative 0.15D. And then if I subtract off my 6 on the other side, I'm going to get 1.35. Okay. Hopefully you see my mistake. If you don't, it's going to pop up to you in a moment. Let's imagine I don't see my mistake, and now I take my next line, which is 1.35, and I divide it by negative 0.15. Okay, yes, we're probably using our calculator for that. So 1.35 divided by negative 1 is negative 9. Okay, what did D represent? It represented my number of dimes. So I have negative 9 dimes. Clearly, I made a mistake. So I start to backtrack. So I look on the line before. Yep, that would have given me negative 9. A positive divided by a negative, that gives me negative 9. So then I look at the line before that. Okay, how did I get? Yeah, on the left side, I should have got a negative. On the right side, oh, shoot. I was calculating 4.65 minus 6. It should have been a negative 1.35. And that's how we can find our mistake. So now I can clear up all of this, and I go, oh, now I'm corrected. And so my D then is negative 1.35 divided by negative 0.15. Notice I didn't even bother to write down the signs because I know that a negative divided by a negative is a positive. We make our calculation, and we are good. We just have to make sure that we answered the question. So question said, how many of each does she have? All I've solved for right now is my number of dimes. That means that I need my number of quarters. And so with a quick calculation of 24 minus 9, I'm going to get to 15. Therefore, we have 15 dimes and, we have 9 dimes and 15 quarters. There we go. So hopefully we did okay on that one. We were good at translating. And then as soon as we can get to that created equation, that first blue line, the rest hopefully just becomes algebra for us. Okay, let's tackle the last problem. Okay, what I'd like you to do now, go ahead, give that problem a read. Pause the video. Okay, so we take a look at the problem, and it says we had 2,000 tickets that were sold to a Raiders game on Saturday. The cost of a ticket for an adult was $4, for a student was $2. The total amount of revenue, and hopefully we're good with the term revenue. Revenue just means how much money came in. So the total amount of money that was brought in was $6,400. How many adult tickets were sold on Saturday? This becomes one of those problems that because the question doesn't care for both, like it doesn't ask how many of each were sold, it just says how many adult tickets were sold, then I think I'm going to start off by saying I'm going to let, and maybe I say A, just to remind me that that's for adult. Let A represent the number of adult tickets. You can write sold, but I think that that's sufficient. Okay, now what I want you to do, pause the video and try to solve the rest of the problem. Okay, pause it now. Okay, we're back. So hopefully, back up in the original, we saw there was our quantity. So it told us that there was 2,000 total tickets that were sold. So if A is the number of adult tickets, then 2,000 minus A is the number of student tickets. Okay, I just used up my quantity information. Now what I need to use is my value information. So I was told that the total revenue, so in my mind, I'm saying if I take my number of adult tickets, add that to my number of student tickets, then it has to equal 6,400. Okay, so what expression represent the adult tickets? That was A. And how much is each adult ticket worth? Well, it costs $4. So it's $4 for every adult ticket that was sold. Add to that $2 for every student ticket that was sold. And that total must be 6,400. Okay, so now what I want you to do, let's take that red equation and let's go through and solve that red equation as fast as we can. So let's solve that thing. Pause the video. Okay, we're back. So hopefully we were able to go through and expand in those brackets, expand in that 2. Maybe I do a little cleaning up on the left side. I can already see that I have to get rid of my plus 4,000, so I'm going to subtract 4,000. Now get rid of my times by 2, so I divide by 2. There we go. Now, right back at the very beginning of this, I underlined in blue how many adult tickets were sold. This is the reason why I chose to make my variable what the problem was asking for. Notice the question asks how many adult tickets were sold. I just solved for A. Well, what was A? It was what the question asked for. It means I don't have to do any other work. I already have my answer. So in order to answer that problem then, therefore, what were the 1,200? They were simply tickets. Put on your units and you are good. Okay, there was us going through some measurement problems followed by some value problems, some money problems. Okay, your job right now, jump in and get as much practice with those areas to make sure that we're pretty fluent with it. Okay, good luck.